Hello guys, let's start by solving some of the questions from the previous JEE mains paper. So coming to our first topic, it's 3D geometry, and the question we have here is we are given a point and we have to find the distance of this point from the plane along this line. So first let's imagine it. How is it? So let's start by imagining a plane. This is this given plane. Let it be x minus y plus z is equals to 5, and we also have a point. Let's assume it to be P, and it's given that distance of this point from the plane. So along this line. So let this line be this way. So along this line, so in the same way this point should also be connected to this plane in the same way. So if it's going through the plane, it has to intersect it some way. Let's assume that point to be Q, and Q be xyz, imaginary xyz. So we know the direction ratios of this line. These are 1, 1, 1 and 1. So as we know along this line, then we can write the line equation of this PQ. So equation of PQ is x minus 1 along that line. So 1 is equal to x plus 5 by 1 is equal to x minus 9 by 1. So now we got the equation of line PQ. So if we can denote all the points which are on the line PQ in the form of, this should be y, this should be z, because we have assumed it to be y, x, y, z. So let the point Q which is on this line PQ, so Q on line PQ can be written in the form x is equal to, let's assume it to be some lambda, so lambda plus 1. In the same way, lambda minus 5, lambda plus 9. So all the points in the line PQ can be imagined it to be this form. So let's think it's point Q. If it is point Q, then it has to lie on this plane. So it should satisfy the equation of the plane. So Q satisfies the equation x minus y plus z is equals to 5. So let's directly substitute this into this one. Lambda plus 1 minus lambda minus 5 plus lambda plus 9 is equal to 5. So lambda cancels, lambda plus 15 is equal to 5, lambda is equal to minus 10. Now we got the value of lambda. Let's substitute this into this. It is minus 9, minus 10 minus 5 is minus 15, minus 10 plus 9 is minus 1. So we got the point Q. Now what are we asked? The distance of this point where it intersects this plane, that is point Q. So we just need the length PQ, which is under root, it is 1 minus 5 9, 1 plus 9 whole square, minus into minus comes plus, then plus minus 5 plus 15, minus into minus same way, then the last one 9 plus 1 whole square. So 1 plus 9 is 10, 10 square is 100, minus 5 plus 15, 10, again 100, 9 plus 1, 10, once again 100. So we have root 300, which is nothing but 10 root 3. So this is the answer. This is the distance between the point P and Q. Okay. Now we have another question from the same 3D geometry topic. It is, we have to find the equation of a plane which is formed through the intersection of these two planes and parallel to y-axis. Usually if we are given intersection of planes, when two planes intersect we get a line, but we are given additional information, it is parallel to y-axis, hence we will be able to find the equation of the plane. So even in straight lines and in other topics, if we are given such equations, then we usually write to find the set of equations to be the equation of this plane as x plus y plus z minus 1 plus some constant lambda into the other equation 2x plus 3y minus z plus 4 equal to 0. So this is the equation of this plane, but we have another equation parallel to y axis. We will use this information to find the value of the constant lambda. So first let's separate this into x, y, z terms so that we can do it easily. It becomes 1 plus 2 lambda into x plus 1 plus 3 lambda into y plus 1 minus lambda into z, then the constants 4 lambda minus 1 equal to 0. We now have it is parallel to y axis. So if we consider the direction ratios 0, 1, 0, and if we take the product, then this becomes perpendicular to y axis. So we will get another equation. It is 0 into 1 plus 2 lambda plus 1 into 1 plus 3 lambda plus 0 into 1 minus lambda becomes 0. So this is automatically 0, this is 0. We are left with 1 plus 3 lambda equal to 0. So the value of lambda comes out to be minus 1 by 3. So all we have to do is substitute this lambda value into this equation. Then we will get the equation of the plane. 1 minus 2 by 3x plus 1 minus 3 by 3y plus 1 minus into minus plus 1 plus 1 by 3z plus minus 4 by 3 minus 1 equal to 0. So we have 3 in all the denominators. Let's omit. Then we have to take LCM. 3 minus 2 1x plus 3 minus 3 0 of y plus 3 plus 1 4z minus 4 minus 3 minus 7 equal to 0. We have x plus 4z minus 7 is equal to 0. That's it. Now we have another question from topic 3D geometry. So let's see it. In the like the first question, we are given a point and asked to find its distance from the intersection of that line and this plane. As I previously said, when a line and a plane intersects, we get a point. So this is the given plane. Let's assume it is x minus y plus z is equals to 16, and this is the line. If it goes through here, we get a point. Let it be some q. Now this q is, we can write this q in the generalized form 3 lambda plus 2, 4 lambda minus 1, 12 lambda plus 2. If we consider this is equals to lambda. Now this point q lies on this plane, so it should generally satisfy the equation of the plane. So the plane equation is x minus y plus z is equals to 16. Substituting these points, 3 lambda plus 2 minus 4 lambda minus 1 plus 12 lambda plus 2 equal to 16. So let's simplify this to find the value of lambda. 3 lambda minus 4 lambda plus 12 lambda, and the constants 2 plus 1 plus 2 is equals to 16. So 3 minus 4 minus 1, so 11 lambda plus 5 is equals to 16. 11 lambda is equals to 11, then lambda value is 1. So let's put the value of lambda here. We get q as 5, 3, 14. So we got the point q, we have the point p. Now all we have to do is find distance between pq. 1, 0, 2. So pq is equals to under root 1 minus 5 whole square plus 0 minus 3 whole square plus 2 minus 14 whole square. So solving this, minus 4 square 16 minus 3 square 9 minus 12 square 144. So 16 plus 9, 25 plus 144, 169, which is 13. So that's the answer. It's the distance between point P and Q.